Hello everyone, welcome back to the Oberon channel, and I think all of you know this was a pre-module procedure from the past where you were entering endless line of strings and numbers and stuff like that just to tell an operating system command how to parameterize it. And now I'm going to show you how this works in Oberon. Okay, I already told you that you can start Oberon commands from everywhere on your system, everywhere in the display space where something is written that is a command, it can be executed. But this is not the only thing. You also can take parameters or input for your commands from everywhere on the system. This is the same flexible, extensible principle. And I'm going to show you how this works in this little example here I've made. This module here is called phrase, and what it does is that you can take a text by selection, and you can start or break it down into words, and single words are stored, and then you can execute a command named make phrase, and make phrase does arbitrary or randomly picking the previously stored words and is arranging them into a new, normally completely senseless type of text. But it's very funny to read this. But my main goal here is to show you how flexible Oberon is in getting input for commands and also managing the output. So I'm going to show you this in a small example. Let's take a text. For example, here we have the Oberon Companion, chapter 5 open, so let's select, for example, this bunch of text here. Okay. Like this. Then we go over to my module I already compiled and click on Phrases Store. And you can see 118 words were scanned. And now we're gonna make a new text file, and we shrink it a little bit like this. We place our caret here, and then we click on Phrases, Make Phrase. And you can see this is the text. The only problem here is that the text is not normally adjusted to the width of the text window, so we have to add some new lines here to make it more readable. So like this. And you can see this text is not making pretty much sense. It's just something to have a little bit fun. The first most important component of this module is a structure to store all the words. That's what I made with these type here. I generated a new type named list, and this is record, and it takes as a one element an array of 100 characters. That's enough length to store nearly every word, and an additional Boolean parameter named placed. This is just used to indicate that this string here was already used in the randomly picking process or not. Then I have this procedure here named store, which can be called externally. And what I'm introducing here is something coming from the text module named scanner and also buffers. Scanner and buffers are something very versatile that you can use in Oberon. I'll show you in a few seconds how this works. The very important command here is something coming from the Oberon module named getSelection. And you can see that you can apply a pointer here to a text object and start and end parameter and something that's called time. And what Oberon really is doing, it looks for some selection somewhere in a display space, and when it finds one, it gives you the text that names the pointer to the text object where the text is selected, and start and end are indicating the start and the end of the selection. Time is just parameter that you can use for the validation. If time is greater than 0, then the validation is positive and we have a selection. What I'm doing here is that I'm generating a new buffer object, also coming from text S. Buffer is something, as the name says, that can store text named characters. A bunch of characters can be stored in the buffer. The buffer here is initialized with the new operator and then initiated by applying the openBuff procedure to the buffer object. Then we generate a second object that is the text type by doing text as new. Text as new generates a new text type and also initializes this, and the pointer to this object is copied to the global variable objects.newObject you already know from my Feigenbaum fractal, and we can pick up this pointer here by doing typecasting to text as.text. And then comes something tricky. We save the contents of this selected text, which is in T1 from start to end, into this buffer we just generated, and then we append the buffer to our newly generated text object. So what we essentially doing here is just taking the selected text and putting it into one text object that contains this text completely, so we don't have to take care anymore for the start and end parameters, because the whole text now is inside one object contained. That makes the handling much more easier. And now we open a scanner. A scanner is something like a parser. You can set it upon some kind of text. In this case, it's our selected text contained in the object T2. And what it does, it breaks the text down into tokens, and all these tokens are evaluated if they are numbers, integer numbers, real numbers, some kind of symbols, white space, or even just plain text. And this is indicated by class identifiers coming from the class field in the scanner object. You can see s.class. And if s.class is text s.name, that is a constant, that means, yes, this is really plain text, not numbers, just plain text. Then we copy this text to our word array. And we set the Boolean field place to false. Then we ink the number, and this is running into this loop until everything is scanned. The original scanning process is initiated by text as scan s. That means that one token is scanned. So we also have to apply this command here in this loop to get the next token. When no more tokens are available, then the field EOT, that means end of text, that's similar to the end of file EOF parameter you know from other programming languages dealing with open files. It's set to false. Yes, it's set to true. When it's set to true, then this loop here is terminated. And the second procedure we can call from the outside is makePhrase. What makePhrase does is nothing more than at first doing this loop here that initially sets these placed data fields in our word type object to false. So that means that none of those entries is skipped over during the random picking process of the random generator. And then something very interesting comes here. The system now is looking if the caret is placed somewhere in a window. This is done by a message. As I told you, messages are so powerful in Oberon, you can do everything you want by messages. So we generate caret message indicated by this parameter c, and we set CID to Oberon get. That means we want to get the information about the caret. All the other parameters are set to nil, and then we do a display broadcast, and we get back the answer, and the text field of this caret message is not nil. That means then the system found some text window with a place caret inside. What we do then is we open a writer. A writer is something that you can apply on a text or something else. That is something like a buffer where you can sequentially insert text and numbers and other things. So this is some kind of buffer you can fill before you apply it to some text window or the log window or something like this. So what's done here is that randomly, by using of a random number generator coming from the random numbers module, picks out randomly words from our word array, and when it does so, then this respective or the related place field is set to true. This is done to avoid that the same word coming from the same position in the word array is placed multiple times. The goal is to get a scrambled text at the output that contains no more words than the original text, and also the probability of the words is always 1. So that means that every word coming from the old text is only placed one time in the new text, and this is done here. We use a buffer from the writer object and apply it by the procedure text as append to the text field, which is still available in the caret message and identifies the text where our caret is placed.